Hello everyone and welcome to the Learning C series part 8. Okay, now I want to explain about dynamic memory allocation. And actually, when we declare a variable using using usual way like like this, like integer a, like this. Actually, when you declare this, it saves it in stack memory, and this stack memory have a limited size. Actually, I think in Linux it's limited to 8 megabyte. It's very limited, but in C actually there are second type of memory. It's called heap, and this heap doesn't have I think it doesn't have limited size, so it's unlimited. It's only limited by the size of your RAM. And now you will ask how to save the data in heap memory. Actually, in C you will use malloc, and there are calloc. I hope I'm not wrong. It's called Bialloc. And I think most of the time you will use malloc here. And yeah, the malloc here is this malloc will return void. Yeah, this will return a void pointer. So when you get a void pointer, you must cast it to the anything, whether it's char or integer or anything. Sorry for bad drawing. If you have a memory allocation and you don't want to use it again, you must free it using this free command. Free command. And the argument is the pointer that you using when you're using malloc here. But instead, you doesn't need to free like malloc here. Yeah, that is the pros of the stack memory. And actually, when you're using stack memory, when you want to allocate in stack memory, it will be faster than when you're using heap or malloc here. Okay, now let's just get over with the theory. Now we will move to the code. Okay, here I already write the code. So in theory, I already tell you that stack have a limited size, right? And I say that the limit is usually is 8 megabyte. Actually in Linux you can check the limit using this command, limit minus s, and it say that this number is in the kilobyte, I think, and it's around 8 megabyte. Okay, for me, when I want to understand the concept, I want the proof, so the concept will be more understandable for me. So now I want to test if there is a if if this limit is real or not. So here I declare the size array, and then I read the size array here, and then after that I declare an array char. The size of the array is size array like this. So this array size must be according to the size array here. So with this technique or with this algorithm, we can test the limit of the stack. Okay, let's just compile. So I think I will just return 0 here, so the program will stop here. Okay, let's run the program. Let's specify the size of the array. Let's say uh, 9 megabyte, and 9 megabyte is actually 9 million bytes. So here I declare 9 million, and then it's segmentation fault or core dampen. But what if we just declare, let's see, 8 million? Yeah, it's run smoothly. There is no segmentation fault. This segmentation fault means that we already crossed the border of the stack memory. So it's error like this. Oh yeah, in the theory after that, I say that heap memory doesn't have a limit. For your information, my laptop here that I'm using for this experiment is have a 16 gigabyte RAM. So yeah, the size of this here I declare the size of the heap will be 9 million. I think this will be not a problem. Okay, here I declare the size heap 9 million, and then after that I am doing a malloc or memory allocation with the size of the heap, and then I cast it as a char pointer, and then if this is success, it will be print successfully like this. And then after that I free the array, or I free the malloc previously. Let's compile it. Let's skip this. Okay, and it's created successfully. So as you can see, 9 million is created fine in heap memory. But if we declare, or if we specify that we need 9 million in stack memory, it will be segmentation fault core dump. But because in my computer in here, the limit of the stack memory is around 8 megabyte or 8 million. Okay, now actually this is the supplementary example for the malloc. Actually, when you coding the real C product or the real C program, you will using malloc mostly to declare or to create a struct like this. In here I already define a house struct, okay, and then after that after I'm using malloc here, I define the value for the struct. Oh yeah, actually in my previous video To access the variable in the struct, I'm using point like this, right? But since the a house or the variable a house here is a pointer, the point is replaced by the arrow like this. So I think this is the supplementary material for the struct video. Okay, let's compile this. Let's skip this. And yeah, this is work fine. If you replace the arrow with the point, it will be not compiled. You see here, you must using the arrow because a house here is a pointer. Okay, I think that's all. Okay, see you in the next video. Bye.